Hello, welcome to Practical Electronics 8. Our topic is design and construction of 4-channel stereo audio signal splitter. That is a passive audio splitter. As you can see, this is the device. This is a passive audio splitter. Uh, what we have here, this is the input, right and left channel. This is the output, right and left channel. Then these are also output for recording. We have one, two, three stereo outputs. So before we take a look at our circuit, let's take a look at this. A signal splitter is a device or circuit that divides an input signal into multiple output signals without significant loss or quality or strength. So a signal splitter, we know that is you have one output signal and then you need like multiple input devices, different separate input devices where that signal need to be fed to them. So in this case now you need a signal splitter that will be able to split these signals into multiple outputs so that you can feed to each of the separate input devices. In this case, um, we are dealing with audio signal splitter, a passive audio signal splitter. So let's come back again. Let's take a look at types of signal splitters. Number one, we have audio signal splitter. Audio signal splitter. This splits an audio signal from a microphone, from an audio mixer, from an headphone jack, and so many others into multiple outputs. So you could have one microphone input and you want to have like 4 outputs or 5 outputs from that microphone signal, or from an audio mixer. The output from an audio mixer, you want, let's say, like 5 outputs so that you can feed to 5 different amplifiers. Or you have one headphone jack outlet. You want that signal to be splitted into like more than one to be fed to other input devices. So let's take a look at the next one. We have video splitter. This device splits video signals, like example HDMI, VGA, composite, etc., to multiple displays. In a situation whereby you have one video output device and you have like 4 video display devices, so you need a video splitter to split these signals. Example, here we have a VGA splitter. So if you have 4 display devices and those devices have VGA inputs, you need a VGA splitter to split this signal into 4 so that each one of them can be fed to the input. If the displays are HDMI, they have HDMI inputs, it means you need to have an HDMI splitter to split it into 4 outputs to feed to those 4 displays. Number 3, we have RF splitter. This device is used in cable TV, satellite, and antenna systems to split coaxial signals. Like you have one RF antenna or one RF receiver, and you have one RF receiver which out one RF output, and you need more than one RF input devices. So you need the RF splitter to split the RF signal to feed to those input devices. The other one, we have a USB hub. This one is very common, like example of what I have here. Like this one we have here, this one is very common. So you can see this is also it's a splitter. This is an active splitter. We'll be taking a look at active and passive splitter. So you can see. So this is one USB port being splitted to 1, 2, 3, 4. So this is a USB hub. It's also a splitter, data splitter. So you see. So let's take a look at active and passive splitter. Active splitter, this type of splitter require electric power to operate. So this type of power require electric power to act. Just example of this one that we have having here, it need power. There are some chips in here, there are some microprocessors in here, they require power to work. Without power, this thing will be useless, it won't work, so it will need power. So these are active splitter, those type of splitter that require electricity for them to work, electric power. Either could be DC or any other source of power. Then we have the passive splitter. This type of splitter does not require electric power, unlike the one I have built here. So this is a passive. You can look at it, there is nowhere you finish for power, either battery or DC input. No, this is passive splitter. So let's take a look at our circuit diagram. Let's take a look at our circuit diagram. Now, just like I mentioned last in some of our previous videos, the essence of us learning creative technology, the essence of us learning science, learning engineering is to solve real life problem. It is out of a real life problem that I was able to sit down and create and construct this. I designed this. So before I take a look at how this works, so let's come to the circuit. So what I'm having here, this is a circuit diagram of this. So before I will go into the explanations, now let me start from what made me to design this. Now if you look at the mixer in my church, as you can see it above there, the mixer has a stereo audio output for recording. I tried recording on that output. I discovered there is an issue with it. So the option is to take the mixer to go and fix, but I have to cancel that option. I now sat down and think of another option, is to build an external splitter that I can be able to feed the output from that mixer. You know, from your mixer it goes to the power amp, and with the faulty recording output on the mixer, I cannot be able to record our church services, because I use a laptop for doing the recording. So it became a problem. I was unable to do recording. So I have to think of a way of creating something that will be able to split the signals. So this input is the signal coming from the mixer. It is stereo, right and left channels coming from the mixer. I looped it to this. This goes to the power amplifier. So what I did was that I did this in the way that when connecting something here, it doesn't affect the signal. So what I did, I used some means of dropping the signals down, so that I can take outputs from here without affecting the output going to the power amp, so that I can feed this to my laptop or any other recording equipment. So I have three, no, here we have 4 channels. This is 1, 2, 3, 4. So that's why it's 4 channels. So also I provided individual volume controls. These are not going to affect the output here. This is looped. I loop this so that the signal coming from here just goes straight to the power amp. So it is only the signals that from here that I have to drop them, their levels, the sound levels. I have to reduce it with this. So let's go take a look at the circuit diagram. So this is the circuit diagram of 4-channel audio signal splitter. So it's a passive, just like I've said, a passive doesn't require you don't need any power supply to this, no batteries, nothing to power this. So it's just passive. So what we have here, these are the inputs, these inputs, these are the outputs. Then what we have here, these are stereo potentiometers. So each one of these that you see here, if I take this, it means there will be no signal going to my laptop. The signal is zero level, there will be no output. So as I take this on, the volume, I'm raising the volume, gradually coming in, bringing it up, so that to my recording software on my laptop. So that's if I'm using these very ports. Then this, if I'm using this, connecting this one to another, let's say a camera. I want to feed the audio from here to a camera, I can use this to control the level. Or I want to still feed this to another audio equipment, I can use this. So that's why it's 4-channel, one, this output here, and these 3 output, making 4 channels. So each of them, they are stereo. So you see. So with this, I have my connectors here. So this goes to this sound card that goes to my computer. So you can see I can now put in here for the recording. So this goes to my USB port on my computer. So this is my sound card. So this goes to the computer. Then these 2 jacks, these 2, I connect this. So this goes to the output of my mixer. The signal output, this goes to the signal output of my mixer. Then from here, I will take another jack like this. I will connect another one here. So this goes to my power amplifier. So the input of my power amplifier. You understand? So as a signal is coming from my mixer to this, the signal is dropped to this output. So if I bridge each of this output, it doesn't affect the signal. So the signal passes straight to the power amp, and also from here they are controlled. So what this does, this doesn't affect the signal that is going out to the power amplifier. It only affects the recording equipment. So you see, so this is how we use this. So if I have another, let's say I have a camera, I need to feed the audio to the camera, I can connect this. Or let's say I have another laptop that's doing live streaming, I can be able to connect this to feed the audio to the other also, which means we have 3, that's making 4 channels. So you can see. So let's go back to the circuit diagram so that I will explain how this. So if you look at this is the input from the mixer. They are looped. So this in from the mixer, the output from the mixer comes through this input. These are the TS and XLR female connectors. So those that we have here. So they are the female connectors for this. So this TS connector. So you see. So then these ones here are the RCA connectors. These are the RCA connectors we have on our audio and video equipment. So so what we have here is these are resistors. So I have to use resistors to drop the signals, the signal level. It doesn't affect the quality of the signal, just the level. I need to drop it because we are taking this for recording equipment. You don't need much signal like the one going to the power amp. So so what we have here, this is one of the outputs, this is another output, this is another output. just like what you're having here. It's a number then 1, 2, 3, one output, two out, three. So that's what you're having here. Then what are these? These are potentiometers. They are stereo, means they are two. When we talk about stereo, they're talking about the right and left signal. They are independent signals. So you are controlling them at once. So they are stereo. So if you want to construct something like this, your potentiometers have to be stereo. So I use 50K. I use 50 kilo ohms. This 50 kilo ohms and potentiometers. You understand? I use 50 kilo ohms potentiometers. So my resistor is 3.3K. You can also use 4.7K to do this. You understand? So these resistors, connecting it with this, we have 53.3K, making 53.3K resistors. So the same thing on this side. So that if I take this, turn this in down, the volume becomes 0, there will be no output here. So these potentiometers only affect the output here. It doesn't affect what is coming out from the mixer to the power amp. You understand? So the same thing, I repeated it. So this is how the input comes from the mixer. The input come in here, it goes from here, it goes to the output, go to the power amplifier. The other channel from the mixer also come through this, it goes to the output. Then from here, the signal from the mixer can come in through this resistor. Now, another reason why I connect, one main major reason why I use these resistors is that to prevent loss of, to prevent distortion and also loss of the signal strength when you are plugging in multiple devices parallel. What we have here is parallel connection. You understand? So what we have here is series. I have to put the resistors in series with this output and the output from the mixer. So I have the resistors in series. You understand? So this resistor is also in series with this potentiometer, so that I can be able to drop the level of the signals. It doesn't affect the quality of the signal, just to drop the level, because this is just for recording. So you don't need a high level signal. You understand? So that's the reason why you are seeing these potentiometers. There are 3 pair of potentiometer. Each of them, they are 2. They are stereo. You understand? So that's how the entire thing work. So if you look at the setup you are seeing up there, as you can see it, so that's how I connected it. That's my mixer, and then my splitter connected. You can see it connected to the laptop there. So as you have seen this, you can build yours. You understand? You can build yours. So just like I have been saying this, the essence of way acquiring knowledge is to solve problems. So here I've solved a real life problem. You understand? Instead of taking the mixer out of the church to my workshop to go and fix it, I look for another option. If I take that mixer out, it's going to affect the service, because I might not be able to fix that quickly. So I have to leave the mixer. I have to cancel that option of taking the mixer out to go and repair it, fix it. So I have to create this. So it means if your mixer is having one output, even if that one output is still working on the mixer, and we want to connect and feed an audio to a camera, and also I want to be recording on the laptop, and also I want to be doing live streaming, it will still be a problem. You understand? Even if those output from that single output from the mixer is still working, in the future it will still going to give us a problem. But with this now, I've solved that problem. So which means I have three outputs for recording, and each of them with having their own controls. You understand? You can adjust their levels independently. So I've been using this making 3 weeks now. I've been using this to do the recording in our church, and it is working very well. It's working very well. It doesn't affect. In fact, even with the recording, I have to leave the level like this way. You understand? With this, I have to leave the level of recording, and the output is very good. You understand? Uh, so thank you for having this time with us to go through this practical for today. So please take a look at the circuit diagram once more again so that you can add this. If you have audio equipment that have one output, you can you can even make multiple up to even 8 outputs. You can make up to 8 outputs. You understand? So if you're making up to, can make up to 8 outputs with this. But in your own case, you can use 4.7K resistors. You understand? If let's say if you're having up to 6, you want to make yours up to 6 outputs, use 4.7K resistor. It's still not going to weaken the signal. You understand? So go here, you don't need a higher large volume. So your recording, you won't still on your recording equipment, you will still have input level controls, which you still going to even reduce it. So this is what I have been able to do to solve my problem of recording, and it's working very well. It's working very well. So if you benefit from this video, please like, subscribe, and also share it. Thank you. See you in our next video.